Okay guys, so this is part 2 of testing for symmetry. I just wanted to give you guys a lot of examples just so you guys could kind of get the hang of um, how to find symmetry and all that stuff, okay? So let's go ahead and get started. Um, let's try this example right here. Let's say y equals to 3x. So this is a pretty general equation, right? This is a line equation, right, with no intercept, so of course this is going to go through the origin. But let's go ahead and see how this acts, okay? So let's do some x-axis test, okay? So if we want to do the x-axis symmetry test, let's go ahead and check that. So what we have to do is, remember, plug in negative y for y. So let's go ahead and do that. So see, I replaced negative y right here where y used to go, and then the other stuff will leave the same, okay? So in order to see if this is going to be symmetrical, we got to try to get it back to the original equation. So like I said in the other video, we could try to divide by -1 on both sides, but we're going to end up in a loop, right? So we'll end up with -3x on this side, and if we try to get rid of this negative, we'll end up with a negative on the other side again, right? So there is no way that we will get symmetry. So this has uh, no symmetry in the x, right? Sorry. Symmetry in x-axis, which is okay, right? We're used to not getting, we're used to not saying no is not right, but in this case it's okay, we don't have symmetry. It is what it is, right? Let's go ahead and do a y-axis symmetry. So for that, we just do the opposite case. So if we're looking for x-axis, we plug in negative y. Well, in y-axis, we plug in negative x. So we have y equals 3 times negative x, okay? And we got to simplify because this isn't totally simplified. Remember, if we have parentheses, that means you're not totally simplified. So we have y equals negative 3x, right? Because 3 times negative x would give us negative 3x. Awesome. So we kind of end up in this loop right here as well, right? So you can see that this side's positive, this side's negative. So we end up getting into the same loop. So if we divide both sides by -1, this side will end up being negative, while this side turns into a positive, which we just still don't want, right? So we would also say this has no y-axis symmetry either, okay? Awesome. Um, Now let's check for origin. So origin, and it's important you guys test everything because sometimes it might look like there's going to be no symmetry, but in this case, we actually will find that we do find symmetry, okay? So let's plug in, so with origin symmetry, where it's a combination of both of these, so we're going to plug in both negative y and negative x. So let's go ahead and do that. So we have negative y is equal to 3 times negative x, okay? And from there, we're going to try to simplify this side, so let's do that again, negative 3x. And right here, we're going to see that, well, let's divide by -1, so let's go ahead and do that. -1, -1, and it works out here, right? So you can see that this side will turn positive, and on this side as well, right? So it does end up working out in this case, so that's why it's important you guys test for all 3 symmetries, and you can see that this equation looks exactly like the original one. So if there is a way to get back to the original equation when you've plugged in negative and a negative for either x or y, that means you have that type of symmetry. So here we would say yes, symmetry for origin. Okay? And that's it. So we have symmetry in the origin. And if we were to graph this, you guys would also be able to see that it actually does have symmetry. So because it doesn't have a y-intercept, we know it's going to be here on the origin, right? And so if we plot it, it's going to go up 3 to the right 1, up 3 to the right 1, and if we graph it, you can see that, yeah, it pretty much looks like it's going to have symmetry across the origin, right? So it looks like it's a reflection and a reflection, right? And that's pretty much it. So this is this one. Let me know if you have questions on this particular example. I wanted to give you guys an example of each at least, okay? So let's go ahead and dive into the next one. Let's try another one. Let's go ahead and do a case where we have Um, let's do a case where we have all types of symmetry. So let's say we had x squared plus y squared is equal to, I'm sorry, not r, equal to 25. Okay? So this is a circle equation, as if you guys recall the circles. Um, so let's go ahead and test this out. So let's look for x-axis symmetry first, okay? So x-axis. All right, so what do we do when we plug in for, when we're looking for x-axis symmetry? We plug in negative y, right? So we're going to do x squared plus negative y squared is equal to 25. All right, so like I said, parentheses means you're not totally simplified yet, and this is because we have a negative y in here, right? So let's go and simplify. So we'll bring down our x squared, it's the same. But here, let's go ahead and write this as a multiplication. So we'll have negative y times negative y, right? And so here you're going to see that because these are both negative, it's actually going to turn this into a positive value, I guess. And you'll also get your y squared back, right? Um, so if we have negative y times negative y, that should give you a positive y squared. And 25 doesn't do anything either, so we just leave it like that. So you can see here that actually this one does go back to the original, right? And we can thank the little squared up here for doing that, because when we plug that negative in, that squared turned it right back into a positive, right? So we didn't have to do any manipulation. All you had to do is just simplify, and you got your original equation back. So good. So we confirmed we have x-axis symmetry. Let's go ahead and do some y-axis. So remember, for y-axis we plug in negative x. So we'll do that. Y squared is the same, and so is 25. So here you guys can see that it's pretty much going to be the same thing that happened here, right? You're going to expand it. You have two negatives multiplying, so it becomes a positive, right? So pretty much here we're going to get our x squared back, and our y squared is still the same, and we also have 25, right? And you can see this is exactly like our, man, I'm really bad at making these arrows. So you can see that, yeah, this looks like our original equation, right? So then here we would also say that it does have y-axis symmetry, okay? And let's do the origin one finally. So origin. All right, so let's do both. So we'll plug in negative x, and we're going to plug in negative y because we're testing for origin, right? And this is going to be equal to 25 still, right? Nothing changes with the constant. So from here, let's go ahead and simplify. So this is a combination of what happened over here, right? So our y squared turned into a positive again, and same thing here, our x squared turned into positive, so you guys can see that this will in fact also have symmetry for the origin, right? So here this is a case where it does have symmetry across all three symmetries. So it's important to not stop either. If you find symmetry with the x-axis, you don't want to just stop and say, oh, well, it's probably just going to have one symmetry. You got to test all of them, right? Because you're never certain. And if you guys always want to, you always want to confirm by graphing in your calculator, right? So this function shows that if you guys remember the standard form of a circle, if you guys remember that, we can easily graph this, right? So that's the standard form of a circle. So we'll say standard form. Sorry. And so we know that if we have these points right here, this is our center. Oops, I'm sorry, this is a K. So H and K. So if we have these two values, we know our center. If, however, we have something like this, we know that we had to plug in zeros right here to get just y and x squared, right? So we know that our center is right at the origin, and our radius is always squared, right? So since this is not a squared number, we must square root it to get our squared value. So the square root of 25 is 5, and we could write that as 5 squared, right? So then our radius is 5, so we'll go up 5. Let's just say that's 5. to the right 5, down 5, and to the left 5. Okay? And then we could roughly sketch this. I'm sorry, I'm really bad, but you could tell that it does in fact have x-axis symmetry, so it reflects across that axis. Oh, I mean y-axis. It also does have x-axis symmetry, and it has origin symmetry, right? So circles have the luxury of having symmetry across every axis, only if they're in the center of your graph, okay? So make sure if you see it like a circle over here, don't confuse it for having all symmetries, right? It is only if it's right at the center, or if it's like right on one of your axes, right? You'll have some sort of symmetry, okay? But at the center, it has all three, okay? Wonder if we still have time for one more. Let's go ahead and do one more. Okay, so let's do this function. Y is equal to x cubed, okay? So let's go through this quickly. So let's see if we want to test for x-axis. We will have negative y, right? So we plug in negative y equals to x cubed. We know from here that we can't do anything, right? So we will say that this has no symmetry. Now let's do y-axis, right? I'm sorry if I'm going a little fast, but this is pretty much just from the previous time, right? You know that if we divide by -1, we'll have all that stuff, so I'm just trying to save some time. So if we're looking for y-axis, we plug in negative y, right? So negative x, so let's go ahead and do that. So here we do need to simplify, so let's go ahead and do that. So we can rewrite this as negative x times negative x times negative x, right? So what is a negative times a negative? This is going to give us a negative x, a positive x squared, right? Negative and negative makes it positive, and x times x gives us a x squared, right? So then we have x squared times a negative x still from over here. So what would a negative and a positive give us? It gives us a negative actually, and this is going to give us a cubed for all the x's, right? So now we have the 3x's multiplied. So now this is simplified. Okay, so now our equation reads y is equal to negative x cubed. Okay, so you can see that the value is still negative, so we will actually have no symmetry here either, right? But now let's go ahead and test for origin. So let's go ahead and do that. So let's plug in negative y, and we're going to plug in negative x. Okay, so from here you can see that the negative y will just come down, and this will actually turn into our negative x cubed like we saw here. And you'll see that it's going to have something similar to when we had y equals, I believe it was 5x or something like that, right? Where here you ended up having negative and negative, which they canceled out. So both of these here you can divide by a -1, and it's going to turn everything positive, right? So this will end up looking like our original equation, which makes this a symmetric function across the origin. Okay, so I hope these videos helped you guys. I know I learn best when I see a lot of examples. If you guys still have questions, let me know. But this is important. Make sure you guys do know this. This is for sure going to be on the test, and if you don't know how to do it, I don't think you'll be able to figure it out. So make sure you guys understand it, okay? And I'll catch you guys on the next video. All right, see ya.